I figured this asteroid hit, and there was, you know, heat and shock wave and stuff, and blew away the dinosaurs. You've all seen the documentaries of the dinosaurs eating, and then, what's that? And then, right, you know? They were the lucky ones. This was just, researching this was just awful. As the asteroid plunged through the air, it would have created a huge shock wave, superheating the atmosphere for miles around it. As bright as the sun, it would have set everything underneath it aflame even before it hit. And if anything did manage to survive that terrible heat, it would then have to withstand the force of a giant shock wave slamming into it as the asteroid tore through the air during its supersonic travel. Okay, that's the end of the documentary part when they look up and get blown away. It gets better. Being so large, the asteroid would have hardly slowed its flight or lost any mass at all before it slammed into the ground. Scientists now know that the impact point was just off the Yucatan Peninsula in Mexico. It impacted water, which isn't too surprising as water covers over 70% of the Earth's surface. A huge section of the Gulf of Mexico would have exploded into steam as the ferocious energy of the asteroid's motion was converted to heat upon impact. In the relatively shallow water there, you see, I shouldn't look up when I'm doing this, because then now it's, am I even on the right page now? Oh, there we go. In the relatively shallow water there, the asteroid still would not have slowed much before hitting the continental shelf. Once it finally hit rock, the impacting mass would have stopped, and the remaining energy of its motion would have flash converted to heat. At this point, what was moments before merely a horrifying scenario turns into complete apocalypse as several events occur at once. Slamming into the Earth's crust, all of those millions of megatons of energy exploded outwards, sending molten rock and vaporized seawater upward and outward. The plume shot miles into the sky, bright and hot as the sun. The impact itself generated a huge ground shockwave, dwarfing any mere terrestrial seismic event and killing everything for hundreds of miles around the impact site. Hope you're getting a sense of the scale of this. Following the ground shock was an air shock, an epic sonic boom. Any creatures within 1,000 miles that survived that initial impact were quite deaf once the thunderclap reached them. But if they were anywhere near the Gulf of Mexico, they wouldn't have lasted terribly long anyway. When the asteroid hit the water, it displaced vast amounts of ocean, both because of the shock wave and through the simple vaporization due to heat. What was created was a tsunami, but one on a huge scale. Now, in December 2004, an earthquake caused a tsunami a few yards high that moved slower than a car, yet killed 250,000 people in Indonesia. That tsunami generated by, the tsunami generated by the asteroid impact was hundreds of yards high and moved at 600 miles per hour. Within minutes of this impact, a roaring mountain of billions of tons of seawater slammed into the Texas coast, scouring it clean of any life. The tsunami marched inland for miles, killing everything in its path with a fierce devastation no tornado, hurricane, or earthquake could ever hope to match. And yet, this impact still had more death to deal. When the asteroid hit, it punched a hole in the Earth right through the crust. The energy of the impact sent molten rock hurtling into the air at speeds of several miles per second. At those speeds, and mind you, this is multiple times the speed of a rifle bullet. At those speeds, the debris would actually go up and out of the atmosphere on ballistic trajectories, like intercontinental missiles. As they fell back down, these ejecta would heat up and burn, replicating the original event, but on a miniature scale, however billions of times over. Flaming rock would fall from the sky like a cloudburst for thousands of miles around the impact point, igniting forest fires across the globe that would rage out of control and fill the Earth's atmosphere with thick black smoke. Essentially, the whole planet caught fire. And back at ground zero, remember there? The impact point itself would have been like nowhere else on Earth. The crater 200 miles across and 20 miles deep was chewed into the crust, its temperature soaring to 6,000 degrees Fahrenheit. Inrushing water, what was left over from the Gulf of Mexico, instantly vaporized, creating more devastation, if such a thing is even possible. No place on Earth was left untouched. Fires blazed everywhere. As the world burned, the atmosphere darkened, letting very little sunlight through. Over time, the Earth cooled dramatically, eventually causing an ice age that would kill even the incredibly tough plants and animals that survived the initial onslaught, which must have really sucked. You know, you're like, whew, yeah, all right. And then, is it cold in here? It's just me. Through sheer happenstance, the asteroid hit a spot on Earth that was rich in limestone and other minerals. The shock wave from the impact and from the ejected rock re-entering the atmosphere created nitrates from this material that then formed nitric acid in the air that rained down over the planet. Moreover, chlorine and other chemicals such as bromine in the asteroid itself were released when it impacted. Catapulted into the upper atmosphere, they were sufficient to destroy the ozone layer thousands of times over. This killed not just plant life, but aquatic life as well. Now mind you, this ozone hole that we're terrified about is just a few % reduction in the total ozone layer. Here we're talking about scouring it clean, just erasing it over the whole Earth, right? I shouldn't have made that noise. No, I can't talk. All right. Okay. Note to self, don't do sound effects next time. Okay. The food chain was disrupted at its most fundamental level on the whole planet. And when the fires died down, as much as 75% of all life on Earth was extinguished. Eventually, the crater cooled, the fires went out, and the natural cycles of the Earth buried the evidence. Life remaining on the planet had it pretty tough for a long time. But with that much devastation, there were many environmental niches to be filled. Life did it as it always does. It found its path, and the Earth repopulated. Now let's fast forward 65 million years. Geologists digging through the rock layers see a dramatic change in composition and color between two different rock strata. Below this change are rocks and fossils from the Cretaceous period, and materials above it are from the Tertiary. This striking discontinuity, is called the KT boundary, and sadly the term CT was already being used by archaeologists, so they had to settle for KT, the K being for Cretaceous, even though it's spelled with a C. That discontinuity would be a mystery for decades, and not just among scientists. Since it marked the end of the dinosaurs, it caught the public's imagination as well. And I remember when I was a kid, nobody knew why the dinosaurs went out. They figured volcanoes, disease, nobody knew. Time-traveling hunters was my best guess. Actually, when I had a job at Goddard Space Flight Center, I'd have lunch with my boss and my coworker. We're big science fiction geeks. We would talk about that. You know, what really sank the Titanic is that every time traveler in the future went back to see what sank the Titanic, and they replaced the whole crew, and there was nobody who knew how to pilot the boat, and it down the went. And there will be a day when I will write that short story. I love that idea. I should tell you what we think was what really happened at Area 51, because the UFOs are only one layer of the secret. What's below that layer of secrecy? I wrote that story. Gardner Dozois rejected it for Asimov. I'll rewrite it one of these days. Anyway, after years of investigation, the smoking gun turned up. A layer of iridium, the element iridium, was found in the rock at the KT boundary. It's an element rare on the surface of the Earth, but common in asteroids. Also, many areas on Earth have a layer of soot just above the KT boundary, probably attesting to the global fires. Both of these pointed right to an impact from an asteroid. All that was needed to clinch the deal was the location of the crater, right? If you have an asteroid impact, you expect to see a crater. Where is it? It, too, was eventually found, centered just off the tip of the Yucatan Peninsula. Now, you might think that a huge crater would be easy to find, but in fact, it's difficult. Millions of years of erosion eradicated many crater features. Plus, the crater itself, which is called Chicxulub, is so big that it can only be detected easily from space. Amazingly, you could be standing in the middle of it and never know it. It's so large but so difficult to measure that scientists are still arguing over its size and depth. I went to Cozumel years ago, and I had no idea that I was standing on the edge of a crater 200 miles across. There's no way to know. Now, after all this, the global destruction, the extinction of countless species, including, of course, the dinosaurs, which had previously enjoyed a pretty impressive 200 million year run, and an environmental impact that lasted for centuries, it might be worthwhile to note that the culprit, an asteroid 6 miles across, would be categorized today by most astronomers as small. Much, much larger asteroids exist. Most never get near the Earth, but there are several of similar size that not only approach us, but have orbits that actually cross the Earth. And for them, an impact is not a matter of if, it's a matter of when. The asteroids had a very bad day, but our day may yet come as well. Okay, thus ends the dramatic reading. Thank you.